let me introduce our next plenary speaker. Mobile communication has been a major growth engine for our industry over the last decade. Now, LTE or 4G has become mainstream for mobile communication. What's next? It is our pleasure today to have Mr. Seizo Onoe-san of NTT DOCOMO come here to discuss the future of mobile communication, 5G and beyond. Onoe-san was named Chief Technology Officer, Executive Vice President, and a member of Board of Directors at NTT DOCOMO in June 2012. He has been responsible for leading the initiative in research and development of analog cellular system, digital cellular system, WCDMA, HSPA, LTE, LTE Advanced, and 5G. He's working on research and development of radio access networks, core network, consumer device, and the cloud service. He has worked at NTT and NTT DOCOMO since 1982, acquiring over 30 years of experience in mobile industry. Please join me to welcome Onoe-san.
Hi, Kevin-san. Thank you for your kind introduction. Good morning, everyone. I'm Seizo Onoe, NTT DOCOMO Japan. Thank you very much for this opportunity to be here today. Recently, I had several opportunities to talk about 5G in such an event. Usually, the audience from telecommunication field. Today, it's a solid-state circuit conference. So here, I like to express my appreciation for your contribution in the solid-state circuit field. Actually, the mobile communication was very evolved so much thanks to the solid-state circuit devices. So actually, the mobile technology and systems are evolved from 1G to 4G, and 5G will be the next. Precise definition of each generation is not so simple. I'll be complicated like this. I will talk this later. Topics is listed here. Actually, my main topic will be 5G, but I'd like to give you some review of the past history and today's status of mobile communications. Then I will start with the LTE update. Data traffic volumes are still growing rapidly. This is DOCOMO's network traffic volumes. And interesting thing is that most traffic are generated through LTE, more than 90%. So LTE's deployment and penetration very quick, so successful. Then we have already shifted the resources from 3G to LTE. We are now in DOCOMO operating 5 bands for LTE. From the blue color to red color, it means some refarming from the 3G to LTE. And now we are providing over 300 megabps data services by using the carrier aggregations. And this year, we plan to introduce 370 megabps by using the new spectrum, 3.5 gigahertz. As such, LTE is very successful globally, and especially for DOCOMO compared with the 3G experience. What was behind the success is we learned the lessons from 3G launch experience. Then the lesson 1 is launch timing. And I have to hurry to the next topic where I discuss lesson 2, smooth path to the next generation. History and future. This chart shows the history from 1G to 4G and 5G plans. Each line shows each decade. As you can see, every decade, every 10 years, new generation technology emerged. And also, just after immediately after the previous generation's launch, we started the next generation research. That was a history of the mobile communications. I used this slide 2 years ago at the Operators Group Alliance meeting, NGMN, to initiate 5G discussions. The message was very simple. It was just time to start 5G discussion. Fortunately, the discussion started. And today, 5G is very hot. Everyone talks about 5G. This is very different from the 4G status 10 years ago or 12 years ago. Very different. I can talk about that. 12 years ago, what was happening? We got already some achievement from 4G research. We succeeded in 100 megabps data transmission in 2003 in the field, and 1 gigabps data transmission in 2004. But look at the 3G business during the 2003 and 2004 time frame. It was miserable. Only a limited number of subscribers there, so 3G service was not so well accepted by the customers in the market. Then, having this situation, we thought that even if we deliver this 4G technology, the 4G technology would never come to the market. So we learned the importance of the smooth path to the next generation. Then DOCOMO proposed a Super 3G concept. This is just a concept, but we have a concrete idea and technology in mind. But at that time, yes, original idea is smooth path to the 4G, but at that time, no one was interested in 4G. Rather than that, people didn't like 4G. So then we used the term 3.9G or Super 3G. Actually, DOCOMO, together with some supporters, 25 companies, co-sources, proposed to the 3GPP to initiate, to propose a study item for today's LTE. At that time, no term LTE. This is the actual description of this study item proposal. No term of 4G, nor LTE, just a long-term evolution as a general words. This was the start of the LTE. Then back to the today. Up to 4G, there was a single technology representing each generation. TDMA for 2G, WCDMA was CDMA for 3G, OFDMA for 4G. For 5G, nothing. Nothing, no technology today. But funny thing is that 12 years ago, there was a concrete technology and idea for 4G, but no one called it 4G. Today, no technology, but everyone talks about 5G. Very different, very different. That's we need some consideration on this. But here I do not want to give you a negative impression about 5G technology. Here I'm just saying that no single technology representing 5G, but we have several technologies, candidate technologies, promising technologies. And also, I like to emphasize that the combinations of technology will create new technologies or solutions. That's point. I will talk this at the last topic. Then here we have some items to be discussed. First one, I pick up a time plan. Yes. Recently, one of the frequently asked questions is regarding time plan. When will 5G be available? That's a frequently asked question. Answer: 2020. Very simple. We are targeting 5G launch in 2020. Yes, and also the Tokyo Olympics and Paralympics games will be held in 2020. So it will be a very good opportunity to showcase the 5G use cases. But Olympics game itself is not a goal, just for opportunity to showcase. The important thing here is that 5G will continue to evolve after its launch. I described here as a 5G plus, but not just 2 phases. But we will have many releases after its launch until 6G emerges. This is the same as the 4G LTE evolved to LTE Advanced smoothly. Same thing. But here, some people may worry about the spectrum. No problem. We can start with the existing available bands in 2020. But here, important thing is that we should implement the future extensibility in the first initial 5G specifications. Then, so that we can expand the bands to up to 100 gigahertz. Then we can expand later on. That idea. Next, I like to discuss the 5G requirements and what is 5G. And this shows the 5G requirements. Pick up from the DOCOMO's white paper. And this is from the ITUR recommendations about IMT vision. Probably you can find so many white papers from different companies and forums and organizations. But good thing is that the idea and vision is very similar, common, almost common to all. Good thing. Probably you will listen to the similar presentations from different speakers in the 5G sessions, in this event and other events as well. Yes, that's good. But it might be boring to listen to the same story again and again. Then I can give you just brief summary of the 5G requirement capability with one slide, this one. Broadband. Broadband is always the key requirement. We continue to pursue the higher performance in the data rate and capacity for broadband, mobile broadband. And relatively new requirements are from IoT or IoE. Actually, ITUR recommendations describe some usage scenarios with massive connections and low latency. This is a relatively new requirements. In addition, for 5G, business models ecosystem being discussed actively as essential elements. That's it. This is 5G. Yes, most players, companies, organizations, forums have a similar view as a goal. However, we see some different views and some difference in the priorities and timing in the balance between broadband and IoT, IoE. That's some controversial issues today. Actually, both of broadband and IoT will be evolved from 4G to 5G. It's okay. Final goal is the same, but different timing and different priority. DOCOMO's view is that our view is that broadband first in 2020. We can accept 5G IoT comes late. We can accept. But other guys, some guys want to give us almost the same or higher priority to the IoT. Different views. But you can see for IoT, we are working for so many standards. Category 1, Category 0, Category M, narrowband IoT, so many standards we are working on for that. So I prefer the fewer steps with significant gains. Then I think this is a better solution. Also, we accept the 5G IoT comes late, but today's ongoing work for IoT could be 5G. At least such standards will work well or play a significant role in the 5G time frame. That's that point. But anyway, this is a little bit controversial status. We need further discussion in the standard meetings. Next, I'd like to give you my view on the technology trends. 5G covers a wide variety of use cases from low power to high performance. And 5G utilizes a wide range of frequency band from the existing spectrum to the higher spectrum, up to 100 gigahertz. Today, we have different technologies for different use cases by using the different spectrum. My kind of dream and ambition is 5G cover all areas. But I know the reality. The reality is that, of course, 5G will expand the area to some extent. However, there will be some different technology. They are already deployed in the world, strong technology there, especially for the Wi-Fi, Wi-Fi, something like that. Yes, this is an actual real story. Of course, the different technology will also, some cases, deployed independently, or in some cases, that has some close, tight interworking with the cellular systems. That will be happening in the 2020 time frame. But look at the more longer time frame, technology trends. So far, cellular mobile technology, the trend was convergence was the trend. Actually, in the first generation, we had many standards, but today LTE is a mainstream of the mobile technology. And also it expanded the use cases to wireless metropolitan area networks. Yeah, I mean the WiMAX evolution will be identical to the TD-LTE. So LTE expanded use cases, but we have some other many technologies and use cases. Broadband and fixed, some extreme cases I added. Again, my preference, my ideal case is that convergence will continue, something like this. But my observation is actually the observation is different. Probably divergence likely to happen. This is my observation in the 30 years time frame. But I'm sure that the next 5 years, convergence direction will continue because we can see the actual movement already, like LTE unlicensed, LTE broadcast, LTE-based public safeties, and so on. Many convergence direction will continue. But some small divergence status in the IoT, but they're small. But in total, the convergence direction will continue. That's my observation. Okay. Next, I'd like to show you some activity, DOCOMO's activity for 5G. We are now conducting experimental trials with world-leading vendors. We have a collaboration with 13 vendors, not only for the network infrastructure vendors, but also the chipset vendors and measurement tools vendors. I will show you some of them here today. Yes, this is a very famous, I don't know how to say it. The collaboration with Ericsson, we achieved a 5 Gbps transmission. And in October last year, Miss International ladies visited DOCOMO R&D Center in Japan. Yes, the ladies enjoyed a demonstration of 4K video transmission over 5G. I got many messages from the ladies, very happy. Actually, they liked 5G and they wanted to use 5G as early as possible in their countries. Actually, most about 70 ladies came from developed countries and developing countries. So even in the developing countries, ladies want to use 5G. So we should, including you, we should contribute for that. That's the point. No. But we have some different story, but I can talk that story. Okay. Okay. Another experiment. We achieved over 10 Gbps with Ericsson, and another trials with Nokia. Through the Nokia collaboration, we could make the radio beams visible by wearing the goggle. That guy, he can see the beams, and he can check, confirm the beam tracking working correctly. That's our trials. Then the last topic about the 5G technology. I have a bit ambitious idea for 5G technology. I'd like to talk about that. This is a long story I don't like. But in summary, people tend to believe that 5G is just a hotspot system because it uses a higher spectrum. But I don't like this story. Then I'm asking my team to achieve a wide coverage system as a cellular system evolution, even with a higher spectrum, like a millimeter wave. I'm asking my team. My team is working for that. For that purpose, massive MIMO will be a key. Yes, massive MIMO can extend the reach distance by narrowing the band. But massive MIMO alone does not provide a solution for the as a system because the massive MIMO does not work in case of the out of tracking. So some problem in the stable operations. So we need a combination of the tight interworking between macro cell and small cells like this. We call it advanced CRAN. So here, by using the combination of the massive MIMO and the advanced CRAN, we can provide a solution. Then this is a massive MIMO story. But here, interesting question. How massive is massive? I was asked not to use that slide, but can I show you that slide? Okay. Actually, last year, in September, in CTIA, I was one of the panelists. Interesting question, how massive is massive? What do you think, how massive is massive? A guy discussed hundreds, but I said that we need thousands. I have some background for this number because I asked my team to achieve a kilometer reach. My team member calculated this. But yes, even with 20 gigahertz, with a realistic size of the antenna, we can achieve almost kilometers, just 900 meters. But here is small numbers described there like this, 77 by 77. 77 by 77. In the calculation, it resulted in the around 6,000. We need a 6,000 antennas massive MIMO. I can't imagine how to implement this. So originally, I thought that massive MIMO is just a brute force technology, just increasing the numbers of antennas, just increasing number, no new idea. So I said massive MIMO is just a brute force technology. But I can't imagine how to implement 6,000 massive MIMO. But I changed my mind. Implementation technology is the key. Anyway, I can't imagine how to implement thousands massive MIMO. I have to rely on the semiconductors and RF devices, evolutions, improvement. So then here I describe some challenges of the solid-state circuit for 5G requirement. Of course, RF devices should support a wide range of. We need some different RF devices for each frequencies. I expect this will be realized. But as I said, we don't need full set of RF flexion band from day one. we need a concrete roadmap for the RF device availability. Then we can make a plan, standards, and deploy. So important thing that we need a roadmap for the RF devices. And of course, the high density implementation, I'm imagining for the massive MIMO. And the processing power and power consumption is very general requirement, but we need to enhance furthermore and more. Especially for the IoT or IoE use cases, power consumption is very key, key requirement to achieve the, for example, the 15 years battery life. We need a low power consumption. Then today, I'm not so sure we can achieve such a massive, 1,000 massive MIMO. But in the past, we achieved many things we had thought impossible. Actually, the 35 years ago, the mobile device's weight was 7 kilograms. At that time, probably no one believed that today we can use such a thin and lightweight mobile devices. Actually, within 20 years, it reduced to less than 100 grams, thanks to the semiconductors and RF devices. Probably next will come. And also another example is 30 or 40 years ago, probably no one believed that we can deploy a 2 gigahertz cellular system. Probably no. Actually, today, DOCOMO started with a 2 gigahertz 3G system as a standalone system. So we have a nationwide coverage by 2 gigahertz bands. Probably 30 years ago, no one believed that. Then I believe that we can achieve the things, but we are thinking impossible today. In the future, we can achieve that. That's the story. My story and my expectation for you. By the implementation of the massive MIMO, we can provide 5G services even in the rural area. We don't need so many small cells. No need small cells. Just only a macro cell or semi-macro cell can cover that even in the rural area. This is a dynamic image of the beam tracking with a 1 kilometer reach. This is exact simulation with different conditions, but it is very good to show you the image of the massive MIMO and beam tracking. So I show you this. Okay. Very last part of my presentation. Today, 5G is kind of boom. Everyone talks about 5G, but I hear some misunderstanding and myths about 5G. I listed here. I discussed some of them, but for example, the second from the bottom means that nowadays, people tend to relate all things to 5G. We should calm down a little bit. We don't need to get on the 5G bandwagon. No need. Yeah. Then, as a conclusion, anyway, we need key devices, semiconductors and other devices, power modules, something like that, for the actual 5G implementation. Then, just last words, let's make 5G the practical technology for 2020 and beyond. Work together. Thank you very much.